Okay, I'm going to do a lesson here on heat problems. Here's the basic equations that we're going to use. Let me talk about what exactly they are. Here's the equations that we're going to use for this unit. Here, E stands for energy. Energy or heat. They can be used interchangeably. They are measured in units of calories. The M stands for mass, and it's measured in in grams. This is delta. That's just a triangle, and it means change in, and this is temperature. So this is just the change in temperature. How much is the temperature going up or going down? And then this right here is specific heat, and that is a constant based upon what substance you are dealing with. Okay, the second equation here, the heat energy is equal to the mass times the heat of vaporization. And if you look down here at the bottom, heat of vaporization for water is 540 calories per gram. If you forget that, you can look on the chart that you have in your possession. Equation 3 is mass times heat of fusion, and heat of fusion is down here, and that's 80 calories per gram. So here's the first problem. Find the energy required to change 75 grams of ice at negative 15 degrees Celsius to ice at 0 degrees Celsius. So if we start with our equation, we're at negative 15 to 0. We're staying at ice. We have no change in state, so this is a one-step problem. So we're going to take mass times the specific heat times a change in temperature. My mass is 75 grams. My specific heat, I'm at ice, and if I look back at the last slide, it's 0.5 calories per gram degrees Celsius, and then times the change in temperature, and the change in temperature is going to be the final minus the initial, so it's 0 minus a negative 15. And when you calculate that, here's everything all nice and neatly typed out. You're going to get 562.5 calories. Another one, find the energy required to change 75 grams of ice at 0 degrees Celsius to liquid water at 0 degrees Celsius. Here we do have a change in state. If you think about our heating curve of water, remember we've got this kind of a shape going on. Well, this is going from here to here. This is across that heat of fusion. And if you look, the heat of fusion is 80 calories per gram. So that's the constant that you're going to take and use as we do this. So we're going to take 75 times 80, and you get 6,000 calories. Here's one where we take and we increase the temperature from 80 to 7. So we're actually removing energy from this example. Again, E equals mass times your change in temperature times your specific heat. The mass is 75. The change in temperature comes from 80 minus 7. So this 73 right here came from when I took 80 minus 7. Specific heat comes right off of your chart. Specific heat for water is 1 calorie per gram degrees Celsius. And when you calculate that, you get 5,475 calories. Here's another example. The energy required to change 75 grams of water at 100 degrees to steam at 100 degrees. Notice the temperatures are staying the same. So we're going from water to steam, so this is a change in state, and it's the long bridge, it's the heat of vaporization, so we'll just take our 75 times 540, and you'll get 40,500 calories. And then how much heat is released when 30 grams of water at 5 degrees is turned to ice? This is a two-step problem requiring two separate equations, and then at the very end you need to take and you need to add them together to get your total. Here we have a 5-step problem. We're going to take with 305 grams of ice at negative 40 degrees Celsius, and we're going to convert it into steam at 115 degrees Celsius. You have to consider each step individually. So let's say we have heat. and we need to find, we're going to go from negative 40 to 0. Okay, we're still going to be ice. We're just going to raise the temperature of the ice to 0 degrees. It'll still be ice. Take the mass times the specific heat, which I'm just going to use a C to stand for because it's a constant, times the change in temperature. So if we take the mass, it's 305 grams. My specific heat for steam is 0.5, and my change in temperature is going from a final of 0 minus a negative 40. So we're actually going to be adding a 40 there. So it's 305 times 0.5 times 40. And when you do that, you get so this is how much energy we need to add to raise the temperature to 0. Now I'm going to take and I'm going to actually melt the ice and turn it all into water. So it's going to be mass times the heat of fusion. The mass is 305 grams. My heat of fusion is 80. So I multiply those two, and when I do that, I get next step, I'm going to raise the 100 degrees to get up to the point where I'm ready to switch into steam. So I'm going to take my mass times my specific heat of water, change in temperature. My mass here is 305 grams. My C is my specific heat. Specific heat for water is 1, and I'm going to multiply it by my change in temperature. So that's going to be 100 minus 0, which is 100. And I'm going to get 30,500 calories. Next step, I need to go across and switch all of the liquid water into steam. To do that, heat is equal to the mass times the heat of vaporization. So my mass is 305 grams again. My heat of vaporization is 540 calories per gram. Multiply those and we get and the last step is to calculate the amount of heat that it takes to raise the steam from 100 to 115. My mass is 305. My specific heat for steam is 0.5. And my change in temperature is going to be 115 minus 100, which would be 15. So 305 times 0.5 times 100 or times 15 is going to give me next. To get my total answer, I am going to take all 5 of my numbers here and I'm going to add them all up, and that will give me the total energy. And when you do that, you get, that's a lot of energy. Okay, last type of problem I'm going to talk about is when we take 200 grams of water at 30 degrees Celsius and mixing it with 150 grams of water at 100 degrees Celsius. We want to know the final temperature of the mixture. Remember, the second law of thermodynamics states that heat gained, or heat can't be created or destroyed, it's just going to be transferred. So the heat lost by one object is going to be equal to the heat gained by the other. So heat is simply mass times the specific heat for your substance times the change in temperature. It's going to be the same thing on the other side. Okay, so when I do this, I'm going to start with my 200 grams of water here at 30 degrees Celsius. 200 grams. And we have water. We're at 30 degrees Celsius. Water is going to be in the liquid state, which makes the specific heat 1. Now the change in temperature is the tricky part for this. Now we know that it's going to end up a temperature higher than the 30, but lower than 100. So to calculate that, I'm going to let x stand for my final temperature. I'm going to take x minus 30 over here. And then on the other side, it'll be the other way around. So my mass here for the second one is 150 grams. Again, I'm dealing with water, so the specific heat is 1, and the change in temperature is what we don't know, but we're starting at 100, and we know it's going to end up less than that, so 100 minus x. I'm going to distribute the 200, so it's going to be 200x minus 200 times 30 is going to be 6,000. For here, I'm going to distribute the 500. Now, what would you do if this was not a 1, but if we were dealing with maybe some other type of substance, it wasn't water and water, then I multiply these two first, and then I distribute that product here, because it just makes it a little bit easier. But in this problem, we don't need to worry about that. Then it's just simply a matter of simplifying. I'm going to combine like terms. I'm going to add 150x to both sides.
Is it weird that I have my Minecraft turned on hard and there's no mobs?
This is confusing. I put my stuff in here for the Christmas project. Thanks. I didn't think you cared, but I just figured I'd just
Not at all. Okay. Then I'm going to take and I'm going to add 6,000 to both sides.
Okay, thank you.
And those are going to cancel out. I'm going to be left with 350x equals 21,000. To solve for x, we divide by 350.
Hey Coach K, what are we doing today? Watching movies.
So our final answer then is going to give you 60 degrees Celsius. So if we take and combine these two things together, we should get something really close to 60 degrees Celsius. Hope this helps.